Recursion. Recursion is the process in which a method calls itself, right? So when a method calls itself, this is known as a recursive method. So in this case, what you do is that you call the recursive method, and then inside the recursive method, it's going to call itself within the body of that method. Now, why would you do that? And how would it work? So to understand this, imagine that you have a problem that we are trying to solve. All right. So we are going to represent this problem as just a square in this case, or a rectangle. So this is our problem that we are trying to solve. Now, what we do is that we call a method to solve this problem. All right. So we will have a method that is going to allow us to solve this problem. And this is what we have been doing so far, and it works, right? You call a method and it's going to solve the problem for you. Now, when we say that a method calls itself, this means that you have to be calling yourself to solve the problem. So if it's a matter of myself calling myself, and I keep doing this, right? If the problem is being solved from the first attempt, then that's done. This is completely useless. Why are we calling ourselves? And the other thing is, if I'm calling myself on the same exact problem, again, that doesn't really do much, right? Now, this means that if I'm going to call myself, calling myself to solve a different part, a sub-problem of my original problem, right? So this means that it has to be a smaller part of my problem that I'm calling myself to solve. So that's basically the whole concept of recursion. In recursion, what you do is that you solve a small piece of the problem. All right. So let's use a different color here. So you solve a small piece of the problem. Okay. And then what you do next is that you call yourself to solve the rest. All right. So that's the whole idea of recursion. I solve a small piece and then I call myself to solve the rest. Now, when would that work? The one thing is that the rest of the problem, the other part of the problem that I'm calling myself to solve, has to match the bigger problem. It has to have the same structure, the same input, the same output, the same solution, right? It has to have the same structure so I can be able to call myself for a smaller piece of my problem and try to solve it. Then what happens next is that you go and solve a small piece of that, right? So in this case here, I'm going to solve this piece and then call myself to solve the rest of the problem. All right. And then I call myself here. And again, what's going to happen is that I solve another piece. And then I call myself to solve the rest. All right. And then until I get to the point where it cannot be broken further, this is the smallest piece of my problem that I need to actually have a solution for it. But the thing is, or the advantage is, that small solution here is going to be very easier, much easier than solving the whole big problem as a whole. All right. So the whole idea here for recursion to work is that your problem has to be broken down into a small piece that you solve, another piece that you call yourself to solve. To call yourself to solve, it has to have the same structure as the bigger problem. All right. And then you keep doing this, breaking down, solve part, call yourself to solve the other, solve part, call yourself to solve the other, until you get to the point where you have what we call the base case. All right. This is like the bottom of the well. This is the piece of the problem that you already have a solution for. So we call it the base case. All right. So that here is the base case. So in this case, if you want to solve it, then you take this piece, base case, which you know the solution for, plug it back in here, and then that piece, bigger piece is solved. Plug it back in here, that bigger piece is solved, plug it back in here, and the whole problem is solved. All right. So that is basically the whole idea of recursion. So how would that work? So let's say, for example, here, we will take two simple problems to understand the concept. The first one, we have a method that doesn't really return something. Instead, it's going to print something. We would like to print hello 3 times or 5 times using recursion and no loops. All right, so that is not where you want to use recursion, honestly. This is just a trivial problem where you can use loops simply. However, we are going to use it to just understand the concept. So if I tell you the bigger problem, the major problem that I have is to print hello 5 times, right? So this is the biggest problem that I have here. Print hello 5 times. So the small piece that I can solve is that I can actually print hello 1 time. And then the other part of the problem will simply be, all right, to print hello 4 times. You see it? So in this case, I solved piece of the problem, which is printing hello, and then I called myself, if I have a solution of a problem, a method that can print hello 5 times, then I have a solution of the method that can print hello 4 times. And the same goes for 3 times, right? So in this case, I have another piece here, which will be a smaller version of my problem, which is to print hello 3 times. All right, and you keep doing this. Hello, and then smaller version of the problem is going to be to print hello 2 times. And then the last part is going to be to print 1 hello. And then the last piece is going to be to print hello. And that is the base case, right? Printing hello 1 time should be easy, base case. All right, and we can do that simply by just printing hello because we were able to do this multiple times. And then once I print this hello, if you look at the output, you will find 1, 2, 3, 4, 5. 5 hellos are printed, and that's it. So in this case here, the way we do this is that I'm going to say, I would like to print hello. This is the method that I want to call, which I can give it how many times I want to print. All right, so now I need to build a method that does that. So public, static, void, print hello. And it's going to take an integer, which is the count. All right. And then what it's going to do is that it's going to do 2 things. The first thing is that it's going to print 1 hello, which is the piece of the problem. And then it's going to call itself, say hello, right, with the count, or in this case, let's make count minus minus, so people do not get confused. And then we can pass the new count as an input, all right, or print hello. That's the name of the method. So again, this is what we did. Print hello 1 time. So if you remember our solution here, print hello 1 time. Here is the piece. And then call yourself again to print 4 times. So when that was 5, this became 4, and I pass it as print hello 4. Then I go back and call myself and print, I say 4, print hello 1 time, and then decrement becomes 3, print hello 3 times. 1 and 2, hello and 1. Now, the problem is, if I continue like this, then I will get to the point where it's 1, right? And I print hello 1 time, I reduce it, becomes 0, and I say print hello 0 times. But I don't really have any count here that says like what where to stop, right? So it's going to keep calling myself infinitely until I cause what is called the Stack Overflow error. All right, so if you look at the error in here that we will get, okay, that would be a Stack Overflow, because we know that whenever you call a method, part of the stack is occupied for that method to work. So in this case, it's going to fill the stack until it's completely filled and overflow. All right, so how do I actually enforce the base case? The base case has to be enforced using the count. If count is greater than 0, only then I would like you to actually find the solution. Otherwise, stop. So that here is going to stop at 5 times, and that's it. All right, so that is the base case here. The base case is that I'm not greater than 0 anymore. I am at 0, and this is the base case. All right, so that here is one example of recursion. Again, that could be just a simple loop, but then again, it actually shows the concept. All right, another more common example is the factorial. The factorial is usually used to show recursion because factorial is a very simple concept that has a clear recursion in it. And in that case, if you remember what the factorial is basically going to be whenever I have an n factorial, this is equal to the n times n minus 1 times n minus 2 times, and you keep going until you start to go down 5, 4, 3, 2, and 1. All right, so that basically is factorial. So if I say n factorial, it's n times the reduction keep decrementing by 1 until you get to 1. So in this case, if you look at it, how can I break it into the same concept of one big problem into a small piece and a smaller version of my original problem? Well, that can be thought of as if I have n factorial, this is equivalent to saying n, the first number, times the factorial of the n minus 1. Right? So that is the simplest form. Now, this is more generic. It's equation form. Let's do it with number. Let's say I want to calculate 5 factorial. The 5 factorial is 5 times 4 times 3 times 2 times 1, right? And if you think about it, the 4 times 3 times 2 times 1 is actually 4 factorial. So in that case, I can say 5 factorial is equal to 5 times 4 factorial. And I can also say that, hey, the 4 factorial itself is actually 4 times 3 factorial. And the 3 factorial is 3 times 2 factorial. And the 2 factorial, and so on. Keep going. 1 factorial. And the 1 factorial is simply 1 times 0 factorial. And my base case is that 0 factorial is equal to 1. All right? This is my base case. Okay? So in that case, that is basically my base case. All right, so in this case here, we can simply say, whenever I want to calculate factorial, I just want to call factorial 5, like this, right? So that method itself is supposed to work as calculating this factorial form. Okay? Now, if I go here and say public static, all right, and let's put it void for now and call it factorial and give it an integer n. Okay. And in this case, what we want to do is just to maybe print, right, the factorial. Now, you could, again, put a loop here and do it. But the thing is, what if I want to calculate it, right? Now, the problem with the void is that the void before with the say or print hello was okay because we were printing hello to the screen. But now we actually want to return this value. That's what this method is supposed to do. All right. So in this case, what we can do is that we can say, instead of doing this, I'm going to return to you the number representing the factorial of 5. So in this case, once I return it to you, you could simply go and just print it if you want to. All right. So that's how it should work. Now it's complaining because we said I'm returning an integer. I promised to return an integer, but I haven't returned an integer yet. All right. So how do we calculate this? Now, what we know is that if I am not equal to 0, I would like you to return to me the calculation of the factorial that is less by 1 than my n. What does that mean? It means that if, all right, n is not equal to 0, my solution is going to be to return the n times my factorial of n minus 1. So that's very simple. If it was 5, 5 is not equal to 0. So my solution is 5 times 4 factorial. And that is true. Right? Now the 4 factorial is not equal to 0. So my solution is going to be 4 times 3 factorial. And so on. Now what if it's equal to 0? This is my base case, right? So if it's equal to 0, then I know that the solution is very simple. It's just equal to 1. That's my base case. All right. And that here is a complete solution for this problem. If I run it, it's going to give me 120, which is the 5 times 4 times 3 times 2 times 1 times 1. All right. So it's working, even though it doesn't look as complicated as you would imagine, right? Because it takes care of it by calling itself for that smaller version. Now, you could visually see this if you go into the debugging mode, all right, to see that that scenario here, all right? So in this case, if we set, let's say, for example, here, set that to be here, and just to be clear, int result is equal to this, and I'm going to say print result here, and then I'm going to set my breakpoint to actually be the call of the factorial 5 call here. So now if I run this, I can actually, and I want you to be noticing here what's happening here, all right? So the moment I step into this call, look at this. It started to call another problem, right? Or called this method with 5, said 5 is not equal to 0, yes. Step into. Now it's supposed to calculate 5 times the factorial n minus 1. Now, notice how this is going to generate a new call for this method, completely new one. Look at this, with the value equal to 4. 4 is not equal to 0, another call. 3 is not equal to 0, another call. 2, 1, 0. And now, once it found that 0 factorial is equal to 1, it goes back and says like, hey, I found the solution, it's 1 times 1. And then it goes back, hey, I found the solution, it's 1 times 2, it's 2. 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 120. So as we keep stepping into, it's going to start to eliminate these hanging threads, hanging calls, until it goes back to the 120 and print that in here. All right. So that is basically how 5 times 4 factorial is like, oh, 4 factorial, I have to go and calculate this. Wait for me here. I will go calculate it. And so on. And it keeps doing this until it goes back. So it goes down and then it goes back all the way up to provide the solution. And that's basically recursion. So what you need to do is that you need to find the problem that has this very specific structure, which allows you to call yourself for a smaller version of the original problem. That is not the case in every situation. And it doesn't mean that everything can be solved using recursion. And many times you do not really find a problem that needs to be solved using recursion like this. So it's an optional thing. It's not a mandatory thing that you need to do to solve the problem. Even this one could be solved using loops. You don't have to use recursion. All right. So it's just an alternative way of solving problems. And that's it.